I'm Gilles Mansens from Belgium. I'm here with my colleague Ruben, and yes, we will present you two topics. So it's two small topics. The first one is about a survey of fungal diversity in silage. It's a study that was done a few years ago by CIPF and some partners, but it was only published at the beginning of this year. And then a few slides about vegetal cover of silos. Every country is trying to reduce the consumption of plastics, and we got two or three farmers followed by CIPF that already stopped using plastics on silo and just sow cereals on the silo. But let's go on. So the first topic, fungal diversity in silage supplied to dairy cattle in Belgium. As I said, the study is a collaboration between a vet center in Belgium, two unis, and the CIPF that was responsible for the sampling. So the aims of the study was to establish the fungal diversity in the silos, but also to try to determine whether the ensilage practices could be correlated with the fungal species that you will find in the silo. First, general information. Fungal contamination induces reduction in feed values. It's also reduced palatability, so it's I think the taste of the food. So the cows take less silage. It has also negative effects on animal health. So all those things will affect livestock productivity. The three genera of fungi producing the most mycotoxins are Aspergillus, Penicillium, and Fusarium. For example, Aspergillus fumigatus produces toxic metabolites that will lead to severe diarrhea, irritability, and loss of appetite. So this is general information. You will see in our study the three fungi that we found were not especially those three. First, we did the sampling. So sampling was performed in more than 100 silos in Belgium. Mainly it was on maize silos, but also on pre-wilted grass silos and sugar beet pulp. Mature silages were sampled at different stages of utilization. So I wasn't there when they did the study, but they went back 2 or 3 times to the silo to take samples along the year in the consumption. And they took samples in moldy and non-moldy parts of the silo. And all samples were stored in the same way. They were chilled until delivery at the lab. And on each sample, they isolate the fungi, they determine the pH, they detect the mycotoxins, realize the dry matter, and evaluate the acetic, butyric, and lactic acids. So that's how they did the sampling. So they took all the time one sample just underneath the plastic, one sample in a healthy part of the silo, and one sample in an infected part, if they were. But you will see that in almost all the silos that were sampled, they found some moldy parts. Pictures. You can see problems directly under the plastic cover, or on the other side in pre-wilted grass, moldy parts in the middle. The identification of the fungi, the samples were placed at different points of petri dishes, and then they let it incubate on the plates for 2 to 14 days at 25 degrees. They realized the purification to isolate the fungi, and then identified by macro and micro morphology features. And so also all the farmers that were involved in the experiment had to answer all those questions. So the aim was to try to make a link between the practices and the presence of fungi. So each farmer gave information about if the silo was issued from a field with crop rotation or not. If it was with crop rotation, what was the preceding crop? The harvest date, the weather at the harvest, that's important. If they've applied additives on the silos, what the age of the silo, the feeding rate, the age, the length of the silo, the type of plastic that they used, the shopping length, the presence of multi-parts, anomalies in animal behavior. Actually, they had to notice anything about the silo. A statistical analysis was done to see if the occurrence of fungi in relation to silage management practices, like I already said. So the management practices were used as variables to predict the fungal biodiversity. And yeah, unfortunately, but in studies, in many cases like this, the result of the statistical analysis showed that the variation in the species was independent of the management of the management practices. So they did a really big job, but finally they couldn't put their finger on one thing.
La conclusion, c'est que Marie, c'est.
So, but they even obtained some information. So visible fungal development was observed in all silos. In total, 37 fungal species belonging to 13 different genera were identified, and 1 to 10 species were isolated from each silo, and the most prevalent genera were Penicillium, Trichoderma, and Mucor. Here, it's, as you can see, the proportion of the prevalent genera was also independent of the crop type. So we found the same fungi on maize silages, on pre-wilted grass silages, and on pulp silages. Most of them were Penicillium, then you had Trichoderma, Mucor, and the rest was one of the 9 or 10 other genera. Relation to farm management and seeding process. So no general cause could be put forward a reason for moldy silages. Already said. Most mold problems were already present at the opening of the silo. So at the first stage, when they sampled, the moldy parts were already there. So the cause must be related to the condition existing at the installation of the silos. And fungal development in moldy spots induce disturbed fermentation. So you got elevated pH and reduced lactic acid levels. Conclusion, actually I already said it. We couldn't put the finger on the fact that will influence the presence. And an interesting thing is that prevalent fungi are tolerant to wide ranges and conditions found in silages. On the side, they also did a sub-project with mini silos. So they used mini silos of 3 liters of PVC, and they put the silage inside. They pressed the fresh material. They inoculate the mini silos with Penicillium roqueforti, Penicillium carneum, and Penicillium paneum. Then they also add 3 different types of additives, and so it makes in the end, I think, 16 different combinations to compare. They opened the silos at 3 different dates in the sample collection, and then they analyze same parameters as in the main experiment. And here they just gave a visual assessment of the conservation, so they gave a score about each silo. This is the different mix that they used. So the first additive was microorganisms and enzymes from the company Haltech Ireland. The second mix was only microorganisms from Pioneer, and the third one was propionic acid. So the conclusion there, between all the small silos, no difference in final pH levels. Object with conservation mixture seems to have a slightly better feed value, but wasn't so much. Initial differences of acid composition, but over time similar results. No notable differences in ammonia composition. And so for the two first additive, we got similar global conservation scores. And the third additive, so it was propionic acid, gave the best conservation results. So if you got question about it, I will go with the second topic, and then we can come back with questions. So the second topic, I will say it's the first topic was about a study. Here it's only observation with two farmers that they're really convinced by vegetable cover of the silos. So to realize the silo, you do it conventionally. It's important to press the silo very well, to create a curved silo in order that the water can flow on the sides easily. You add a layer of pressed beet pulps. So thanks to the heat and the moisture of the pulp, the cereals will germinate really fast. So you sow the cereals on the silo by hand. You must put about 1 to 2 kilograms of cereals per meter square. For sure, you don't use cereals that are treated. You use cereals from your harvest. Winter barley, it seems to be the most suitable, and mixture of cereals can also be used, and you can see after 2 days it's already germinated. And here it's a picture of one of farmer's silo. As you can see, you got on the top the vegetable cover composed of winter barley. Then you got an intermediate layer of pressed beet pulps and of the root system of the winter barley, and underneath the maize silage. The farmer there, it's not for dairy cattle, but for cattle for meat, and he gives everything. Most of the time, except sometimes he got some infection and he has to throw it away, but mainly he can give also the top layer to the livestock. The advantages, so the cost, it's inexpensive. You don't have to buy plastic cover. It's time saving at the preparation of the silo, but also at the consumption. The full silo is given to livestock. You've got no waste. It has a good landscape integration. You don't have problems of rotting, making holes in the plastic, and also no problems with the birds. But you also have disadvantages. You can lose, possibly lose the top of the silo. You can lose dry matter, and you also have the presence of more butyric spores. I guess that there must be more disadvantages. Otherwise, we should have a silo without plastic everywhere. At the moment, like I said, it's the observation of the farmer. But CIPF, so the place where I work in Belgium, we are planning within the next years to realize a real study and compare silos with plastic, without, to see the development of the fungi again. And I know that there is, I've read that there is a guy, I think in Alsace in France, that realized it's kind of powder that they put on the silo, and finally they also give it to the livestock. I don't know if you know about it, the guy from Alsace, but he keep the receipt secret. Yeah. Thanks for your attention. So that was two small topics about